Now, for question 3, you have here a rectangular block, okay, with surfaces F, G, and H, which is placed on a wooden surface, all right? So obviously here you have a rubber band that is stretched, okay? When the block is put against the rubber band, surface F is in contact with the wooden surface, okay? Now, so if I ask you what are the two forces acting on the block when the block is released? So besides gravitational force, so you all know that there is gravitational force involved, right? Acting on the block. At the same time, when this block is released, it's going to move, right? So definitely there's going to be frictional force, okay? So other than frictional force, there is one more. So here you have a stretched rubber band, all right? You have a stretched rubber band here. Okay, so naturally when there's a stretch rubber band, you know that if I stretch it, there's going to be elastic spring force acting on it. And because it causes the block to move, there will also be elastic spring force acting on the block as well. Okay, so these are the two forces other than gravitational force, nothing else. Now we move on to the next one. Questions, please ask, okay? This one is nothing new to us, right? So you have here the experiment that is repeated with different surfaces. You have G and H, okay, of the same rectangular block in contact with the wooden surface. By now, you all will know, right? If I ask you again, what affects friction? You know that this block is going to move. So naturally, there's going to be friction, okay? So again, if I ask you, tell me what affects friction, right? We all know the first one is definitely mass. Okay, there's going to be mass affecting friction. And what is the second one? Can someone tell me?
Texture.
Yes, thank you. Texture. Texture. All right, whether it's a smooth surface or a rough surface, there will be texture. And we all know the area of contact with the table, the area of contact doesn't affect friction. Now, again, the next thing to note, okay, if they say based on the results in the table above, what can we conclude about the surface area of a rectangular block and the friction between the rectangular block, okay, there's a spelling error there, it's supposed to be block, and the wooden surface. So if they say based on the results in the table, please remember, you have to always give evidence first. Don't just tell me, oh, the surface area doesn't affect the friction. Okay, don't tell me that yet. Always must give me evidence. Always must tell me based on the results. How do you know that the surface area doesn't affect friction? Okay, so back to this one. Like I said, based on the results above. So what is the evidence that you need to give here? Nat, can you try this one? How do I give evidence first, Nat? I always have to talk. The evidence comes from where? The evidence comes from the table, right? So how do I teach you, always start with the word comparing. What are you comparing? In this case, what can I compare?
Surface.
Very good. Which surface can I compare? In this case, can I compare all three? In this case, I can compare all three. Why? Because when the area of contact of this block with the table are different, can you see 250, 200, 300? When they are different, what do you realize about the distance moved by the block?
Remain the same.
Correct. Because when what's your evidence, all of you? So I have to always start with the word comparing. I say comparing surfaces F, G, and H. When the area of contact, don't tell me increases, you must say when the area of contact of the blocks with the table is different, right? When they are all different, the distance moved by the block remains the same. Understand? That's why I know that the surface area, after that you just conclude nicely, the surface area of a rectangular block and does not affect the friction between the rectangular block and the wooden surface. Do you all follow? The one at the bottom is not clear. Can I read to you all what I wrote at the bottom? Basically, it's just telling me, hence, the surface area of a rectangular block does not affect the friction. Okay, it's just here. Does not affect the friction between the rectangular block and the wooden surface. That's all. So the first thing is always your evidence. Okay, you compare your evidence here. So this is your evidence. You describe. Okay, you compare surfaces F and G also can, or you can always compare the three surfaces because you know that the distance moved by the blocks are all the same. Okay, when the area of contact of the blocks with the table are different. Hence, you just write your conclusion. You answer the question. You tell me it doesn't affect. the surface area of a rectangular block does not affect the friction between the rectangular block and the wooden surface. That's it, okay?